Howdy. The chicken rock. I took a break and I noticed that the very little amount of snow which is on that rock made somehow some features very nicely visible. Cracks and quartz veins. They are transverse towards each other. Same rock, different angle. And you have straight lines, kind of quartz veins. That's another angle again. And you can see also those little lines on the rock. They are in dry conditions not that well visible. Yes, they are, but I thought that's very neat since there's just a little bit of snow. This was the sky last night. That's a little bit blurry picture. That's sometime later. Still later. This is about some 3 hours ago or something. That's from today. Again blurry. Because it keeps it so long open. My hand isn't so steady that it would be perfect. But you can see there's obviously some light thing going on. And I have no idea what this could be. Probably street lights. Yes, the red ones below, or how, like here, down here. This could be street lights reflecting in the clouds. You know, basic stuff. But what's the green thing above it? And why is there different colors? And it seems somehow that there are, it's really hardly visible. There are these kind of vertical things to them. I don't know if you can see them. Maybe it just looks like that due to how the camera works or functions, or I don't know. But they are also in a way visible with bare eyes. And there is this kind of brighter thing here in the middle. The same picture, a bit enhanced. And I don't know, there shouldn't be like really geomagnetic activity or something. Especially not the second day in a row. What? I don't know, it's just interesting and fascinating. I took my time and gave him time to load for many minutes in order to get a glimpse of what is going on in the bigger picture, because you can zoom out much more. And there is something going on. But there's the other one. But that's huge. But as I sat there, ate my self-made stone oven pizza, I noticed a pattern. Since we are watching at patterns here, there's patterns here as well. We got this, whatever you blanket you want to call it, some time ago, totally free, and we were watching at it and thought that, yeah, that's in a way pretty ugly. You know, the color, and it's shiny, and you know. But since it had a perfect size, we started to use it, and I was watching at patterns, and then I was watching at this one. And after a while, I thought that that's pretty amazing. Because you can draw with one line, a spiral, and basically a sphere. Here it touches, here it doesn't, but you could draw it like that. It would touch. So that's just probably a style question. But there is also a hexagonal visible, because it has these dots. There are 6, which I don't think is any coincidence. And here is just this version, and I try to somehow, you can go with one color into the center and you go back with another. And you can continue this. And it can go in both directions. It can always go in both directions. And I think, it was very interesting to watch this kind of basically ugly, whatever you want to call it, housing thing with this very interesting pattern. Because it made me think about many things, like close packing of equal spheres. In geometry, close packing of equal spheres is a dense arrangement of congruent spheres in an infinite regular arrangement or lattice. Carl Friedrich Gauss proved that the highest average density, that is, the greatest fraction of space occupied by spheres, that can be achieved by a lattice packing, is this. That's why snowflakes have the shape they have. And in the same picture, we have also a spiral. And if you were to take just a part of that, you would get this, which is basically a cut through a spiral. The surface conductivity anomaly of Scandinavia. So maybe we should still check out this windy thing. I don't know if you can see it on the phone, but yeah, so here it is. Watch at that. That's massive. And it is pulling cold air from the Arctic, as it is pulling air, warmer air from the Gulf of Mexico or something. And we have very nice, this kind of bow shock or whatever it is. I made videos about this many times. I still don't know what's the reason or what's the mechanics behind that. But I just thought this is very neat. And it's very massive. Look at that. There is definitely something going on with the weather. And as I waited for Windy to load, I remember that there was this interesting article I stumbled across just before, when I searched quickly for a picture of a galaxy. So, Mountainwater and White Rivers alarm. If you don't want to hear anything about these, stop listening. But for those who still want to listen, researchers develop a new method for analyzing rock glaciers. That's some 2 days old or something. Check it out. Like I have been saying, I think glaciers are contemporary lava streams made of water. And they would fluctuate. There might be other things than just water in those. Sometimes they grow, sometimes they shrink. Fluctuations. There can come quite a lot of water out of any spring, basically. A drone image of the Sourdough rock glacier flowing down from Sourdough Peak on August 2021. Yeah, that's quite a view. Standing on a rock glacier is what Tyler Meng imagines would be like to stand on the surface of Mars. The glacier's barren and wrinkled landscape looks like silly putty that's dropped under gravity's pull, offering few clues that a frozen, debris-laden giant lurks beneath the surface. I haven't read it yet because I didn't have time. But anyway, rock glaciers are so named because unlike pure ice glaciers, they are a mix of frozen water, sand, and rocks. They are generally found at the base of steep mountainsides or cliffs that have slowly dropped rock debris, which then mixes with glacier ice and refrozen snowmelt. The rock glaciers also exist on Mars. Really? Cool. Meng, who is pursuing a doctoral degree in planetary science at the University of Arizona, with a minor in geosciences. Minor? Anyway. Is the lead author of a study in the Journal of Glaciology that describes a new method to determine rock glaciers' ice thickness in the ratio of ice to debris, allowing for more precise measurements of these glaciers than previously possible. Meng and his advisor and co-author Jack Holt, Arizona planetary science geoscience professor, used this information to create maps of 4 rock glaciers in Colorado, Wyoming, and Alaska. Colorado. Their work and future work that uses this method will allow scientists to better understand water resources on both Earth and Mars. Water resources. Glaciers. Interesting. As well as how resilient this type of buried ice will be to changing climate on both planets, more than ice. Rock glaciers are hidden and insulated by debris on top of ice. You know, according to common theory, glaciers are born because they are accumulated snow. And now we have the opposite. There's like rocks on top of the snow. For whatever reasons. Maybe it just crumbled down, weathering. Yeah, it's possible to some degree, I guess. Anyway. And their movement is affected by the rocks trapped inside of them. You can think of the rocks like an insulating blanket, Meng said. Beyond a certain thickness, insulation basically turns off the melting, allowing for the ice to be preserved and slowly move or flow down a valley at elevation and temperatures where clean ice may be completely melted. Both pure ice glaciers and rock glaciers, yeah, maybe we should invent also metal glaciers, can move across landscapes very slowly. However, the debris in rock glaciers causes them to flow even more slowly than ice glaciers, as the inclusions of rocks make them much stiffer. They are also typically smaller and thinner than clean ice glaciers, measuring just a couple miles in length and a few hundred or 1,000 feet wide, between 50 and 200 feet thick. Ice glaciers, in contrast, can be many miles in length and thousands of feet thick. To collect the information needed to map and characterize these hidden giants, Meng Holt, other Arizona students, and their collaborators hiked rugged mountain terrain in the western US, lugging computers, battery packs, and radar antennas on their backs. They navigated steep landscapes with loose rocks ranging in size from grains of sand to houses. Standing on a debris-covered glacier is pretty surreal, because it's in this barren area on a mountainside, and each rock glacier seems to have its own personality, Meng said. They each have slightly different type of bedrock supplying debris, and the valley geometry dictates its shape and appearance. Using 2 different antenna configurations, the researchers used ground-penetrating radar to measure both the radio wave speed and the angle at which the wave was reflected from the surface. In the same way that humans have two eyes to see in 3 dimensions, two antenna configurations allow the researchers to better calculate the dimensions of the rock glaciers. They also estimated the ratio of ice to rock at each survey location using radar wave velocity. In the process, we made the most precise estimates of rock glacier geometry and composition to date, Meng said. Lead author and graduate student Tyler Meng standing with radar and a sourdough. From Earth to Mars, understanding rock glaciers on Earth is important because they are essentially water reservoirs, Meng said. Our research gives us a better idea of the total water budget in mountainous regions where major rivers have headwaters. Aha! He said. Snow is a year-to-year accumulation that covers an entire landscape, whereas rock glaciers are more localized but permanent water reservoirs that actually stores water for what could be hundreds to a few thousand years. Or it is just a well from the ground, you know. The researchers are continuing their analysis to understand signs of past climate change in rock glaciers and how these glaciers might have evolved through past climate changes. But having a map of debris thickness and ice concentrations, we can essentially characterize the ability of rock glaciers to withstand the effects of a warming climate compared to clean ice glaciers, Meng said. Other scientists also recognized rock glaciers on Mars by their wrinkled putty-like flow pattern, even before radar data detected them. Yes, mud flows. Ah, man. Martian rock glaciers are still not well understood, Meng said, but it is also known that they are typically found between 30 and 60 degrees latitude on both of the planet's hemisphere and are much older than Martian polar ice. These Martian rock glaciers are potential targets for water resources on Mars, too, because they're actually really large compared to the ones on Earth, like hundreds of meters thick, Meng said. They're also more accessible than polar ice because spacecraft wouldn't have to change their orbits as much as they would if they were to land on a pole, which requires a lot more fuel to reach. Really? Maybe it's just not possible because of the electromagnetic currents. But anyway, one of the big challenges for scientists is determining the thickness of the surface rock covering the glaciers of Mars. If there is 30 feet of rock and debris on a rocked Martian terrain, then it might be not worth the trouble for astronauts to attempt to access the ice for water resources, Meng said. Our goal is to use these rock glaciers on Earth as an analog for processes on Mars, Meng said. By mapping the patterns of debris thickness on Earth, we are trying to understand how the debris thickness may also vary on Mars. Also by learning about the differences in flow parameters between clean ice and debris-rich ice. That will help simulations for the Martian case as well. Moving forward, Holt's research group is continuing to make similar measurements using surface-based radar while collecting new data using drones. This drone-based data collection will help the group to gain a more complete understanding of rock glaciers and subsurface characteristics, while also testing new geophysical methods that may be used in future exploration of Earth and Mars, Meng said. But anyway, this was very long. I think I leave it here. Thanks. Bye. Yes, maybe there are something really else, glaciers, than previously thought. You know. You know the story. But anyway, thanks. Bye.